The massive use of speech in human-machine interaction actively shares a variety of personal identifiable information deeply encoded in our messages. As users have gained understanding of the implications that this sharing has to their privacy, social concern has enabled the legislation that enforces the careful treatment of speech data, such as the European GDPR. The work in our paper relates to the task of speaker anonymization, one of the many steps that need to be taken in addressing privacy-preserving speech technologies. Speaker anonymization seeks preventing the recognition of speakers by maximizing the equal error rate of an ASV system, while preserving the usability of the resulting speech in automatic speech recognition. The work presented in our paper, which was partially used as one of the baselines of the VoicePrivacy challenge, proposes an anonymization algorithm based on the McAdams coefficient. It is a signal processing-based computationally lightweight approach as per comparison to deep learning-based solutions. Its pipeline, represented in figure A, consists in framing unprotected speech to perform LPC analysis. Resulting LPC coefficients are converted to poles, the angle of which is rotated thanks to the McAdams coefficient, parameterized as an exponential alpha, which quantizes the degree of protection once speech is resynthesized. As the coefficient value separates from 1, with effects as we can see in figures B for the pole zero map and in figure C for the effects on formants, the speaker identity information is distorted, doing so at a cost for intelligibility. This enables for a trade-off between protection and usability based on the choice of the parameter. In our work, we explore different angles of the protection that can be achieved by the proposed algorithm. We analyze the impact that the choice of the McAdams coefficient has on performance, with emphasis on how randomly sampling its value from varying ranges can offer increased protection. As another aspect, and because anonymization performance is directly affected by the degree of information to which an attacker has access, we study the efficacy of the system in a variety of cases, such as the worst-case scenario where the attacker has had access to the anonymization scheme and retrained its ASV and ASR systems. We finally discuss how an adequate use of the McAdams coefficient can lead to robust protection while offering a good trade-off while preserving usability. To summarize, we present the enhancement of a technique originally developed for signal processing-based speaker anonymization in the context of the VoicePrivacy challenge. We analyze in detail the efficacy of the form and shifting-based McAdams coefficient to the task, and we evaluate the effect of that various degrees of information in the attacker's hands have to the robustness of the method. Results show that the McAdams coefficient anonymization achieves a competitive and robust performance while being computationally lighter than other competing solutions. Thank you for your time and see you at the session.